Hi guys, welcome to this series of lecture on the basics of mechanics. In this series of lecture, we're going to see about the basics and fundamental concepts of mechanics, which will help us to lay foundation for solving advanced and complex engineering problems. Now, what is mechanics? Mechanics is by definition is the study of force acting on a body and the resultant motion of the body due to the applied force. Let me give you a short example. Let us consider a metal object. This may be some steel or something. And let us consider a flexible object, maybe a sponge or a blob. So this is metal and this is blob. Alright, so if I'm applying force in this direction and if I'm applying force in this direction for a blob, then this metal would deform into something like this, and the blob would deform into something like this, or it will take some random shape. Now mechanics is the study of all these behaviors, right from applying a load to a body and understanding about the deformation behavior. Now as you can see, when the metal is subjected to a load, it will deform in a particular fashion. It's not necessary that all the metal should deform in this way, but this is just for an example. But on the other hand, if something flexible is subjected to a load, it doesn't have any linear method of deforming such as for the metals. Now this is just an example to show you that not all materials would deform in a similar way, so that we can apply one universal rule to all materials and understand their mechanics. Anyway, we will come back to all these stuffs in later part of the lecture series, and now let us concentrate on studying about the very basic fundamental of mechanics, which is nothing but force. Talking about force, to learn what the force is, we need to understand the 3 Newton's law of motion. Now, in this video, I'm going to give you a short overview about all these 3 Newton's law of motion. I'm not going to give you a proper definition. Instead, I'm going to make sure that you understand the Newton's law of motion conceptually. So, let us begin. Now, the Newton's first law talks essentially about the change in state of a body. So for example, if a body is at rest, then you need to apply some force in order to change its state from rest to motion. And similarly, if a body is in motion, then you need to apply the same amount of force that is required to stop the object from moving in the opposite direction, so that you change the state of a moving object into rest. Now, Newton's first law is a bit more than this. It essentially talks about the net force acting on a body. So, net force summation of F. Now, this net force is what that defines whether the object is in motion or is in rest. Now, Newton gives a short condition that if, for example, the net force acting on a body is equal to 0, then we can conclude that the body is at rest. If the net force is not equal to 0, then we can conclude the body is in motion. Now, consider a short example to understand this. I'm having a surface above which a body is just resting. This body has some mass. Now, I'm applying 1 Newton of force from left to right, and at the same time I'm applying 1 Newton of force from right to left. Now for now, just for this example, let us not consider about the body weight and reaction forces, which we will learn about them in the later part of this video. Let us try to calculate the net force acting on this body. So net force summation of F is equal to 1 Newton. This force is actually the one that is acting from left to right, plus the force that is acting from right to left, which I will represent as minus 1 Newton. Because force is a vector quantity, you have to consider the direction at which the force is acting on. So if I take the force which is acting from left to right as a positive force, and I have to take the one that is acting from right to left as a negative one. So the algebraic sum of these two forces will be 0 Newton, and that will be our net force. So since our net force is 0, we can safely assume that the body is at rest. Now let us consider another example. In this case, I'm changing the value of the force that I'm applying from right to left. So if I'm applying 2 newtons of force from right to left, then I have to consider minus 2 Newton when I'm calculating my net force. So in this case, I will have minus 1 as my net force acting on the body. Now the negative sign will define the direction of the movement of the body, and 1 Newton will be the overall force acting on the body. So typically this body will be moving in this direction, and the force that is causing this movement would be 1 Newton acting from right to left. So this is what essentially about the first Newton's law. It does not talk just about the change in state of the body due to applied force, but it also talks mathematically about the overall net force acting on a body. If the overall net force is equal to 0, then the body is at rest. If the overall net force is not equal to 0, then the body is in motion, and the direction of motion will be defined by whichever force that is larger than the all other. Let's now move on to the second Newton's law of motion. The second Newton's law of motion talks essentially about the momentum of a moving object. Now, what is a momentum? Well, momentum is mathematically the product of mass and velocity. So, for example, if a body which has some mass and if it is moving with velocity, so the momentum of this particular moving mass should be equal to m times v. So as you can see, the momentum p is always proportional to the mass of the moving body and the velocity with which the body moves. So what does this essentially means? The more the mass and velocity, the more will be the momentum. So this is why this term momentum is fairly used in sports. For example, a sports team keeps winning 2 to 3 matches in a row, then the commentators would refer the team has momentum on their side. So which means they are on a roll, and it takes a great effort to stop them. So that is what essentially momentum means. So if a moving body has a great velocity and a great mass, then the body will also have a great momentum, which means you would need a lot of effort to stop the moving object and bring that to rest. Now, alright. Now, with that said, what does momentum has to do with the force? Newton says the force applied on a body to make it move is always proportional to the rate of change of momentum of the moving object. Considering the mass as a constant, then we can safely write F is directly proportional to m times dv by dt, right? Where v is the velocity of the moving object, m is the mass, and F is the force applied on the body. Now from this equation, dv by dt is the rate of change of velocity, which otherwise also known as acceleration. So we can write the force applied on a body is equal to mass times acceleration. Now this is actually the definition of force, and this is why in many mechanical engineering problems you can actually measure the acceleration from accelerometer to calculate the force acting on a body. So just to digest this formula, let us assume, for example, a mass of 1 kilogram is moving with the acceleration of 10 meter per second square. Mass is equal to 1 kilograms. Then the force acting on this body would be 1 kilogram times 10 meter per second square, which would be 10 Newton. Alright, now that's it with the second Newton's law. Let's move on to the last and final Newton's law of motion, which is the most famous of all these three. So the third Newton's law. Well, third Newton's law is, like I said, is the very famous of all the three Newton's law, because you might hear people say for every action there is an equal and opposite reaction. Well, that is pretty much the third Newton law of motion. But anyway, nevertheless, we will, however, see a short example and understand how this Newton's third law will come into practice when we have two bodies in contact with each other and transferring forces. Let us consider a body A is resting on another body B. Now, assuming the mass of body A is equal to 2 kilograms and mass of body B is equal to 5 kilograms, then due to gravitational pull in this direction, A with mass 2 kilogram will exert some force on B. And this force due to gravity is nothing but the weight of an object. So the force from A to B would be is equal to mass times acceleration due to gravity, which is nothing but 2 times 9.8, which would roughly be 19.6 newtons. So this A will exert 19.6 newton of force on B. This is the force. This is the action force from A to B. This is acting downwards, and Newton believes that there should be an equal and an opposite reaction for this particular force which is acting downwards. So there will be theoretically a force FBA which will be equal to force FAB, but it will act opposite in the direction of FAB, so negative of FAB. So what does that means? There will be a reaction force from FBA which is equal to minus of 19.6 Newton, and this negative 19.6 Newton will act back from body B to body A. So that's pretty much it. These are the 3 Newton's law of motion, and with this basic knowledge of Newton's law of motion, let us try to draw the free body diagram of an object that is resting and an object that is in motion. So what is a free body diagram? A free body diagram is a simple representation of a body which is subjected to force. So if you consider some body which has a complex amount of forces, then you can represent this particular body in a simple shape like a rectangle or maybe like a square or whatever the shape you would like, and then you just draw arrows to represent the forces acting on this body. So that's what we're gonna do. We're gonna consider a body which is at rest and a body that is at motion, and we're gonna draw all the forces acting on these two bodies and try to understand the Newton's law of motions. So let's begin. We have a body which has some mass, and this body is now resting. Now from third law of motion, we know that the weight from this body will act downwards due to the acceleration due to gravity, right? And this body is also in contact with the surface, so the surface would give some reaction force back. So let us consider the force due to gravity be F, and the reaction force from the surface below will be R. There are no more force acting on this, so let us try to calculate the net force acting on the body. So net force of summation F is equal to F plus reaction force. So from third law of motion, reaction force is R is equal to negative of F, because it is equal but in the opposite direction. So we can write F plus minus of F, which would be again 0. So now we have 0 newtons as our net force. So when we have the net force acting on a body as 0, then the body is at rest. That's what the first law says, right? Now let us consider the body in motion. So let's consider another body. Now this body is moving on this surface. The body has some mass. Now, like in the first case, this body will also exert some force in the downward direction due to acceleration due to gravity, and here as well we will have some reaction force from the contact surface. So this F and this will be R like in the previous case, and the body now is in motion, which means in this direction we have some force. Let's call this as force motion. Now you can see that this body has some contact with the contact surface. Now when two bodies are in connection, then you would also have an additional force due to friction, and this frictional force will always act in the direction opposite to the motion of the body. So for example, if the body is moving here in this direction from left to right, then the friction force would act in the direction of right to left. So I will define that force as Fr. So fine, that's it. So apart from this, there are no more forces acting. So let's calculate the overall net force acting on this body. So the overall net force acting in the vertical direction would be equal to the force due to the acceleration due to gravity, F, plus the reaction force. In this case would be minus of F, which would be equal to 0 newtons. So the net force on the vertical direction would be 0 newtons, but if we calculate the net force on the horizontal direction, let me move the entire thing a bit up. Now it's fine. So let's continue with our calculation. So the net force on horizontal direction summation of Fh is equal to force M, which causes the motion, plus negative of force friction, which I represent here as minus F of R. So this would be equal to Fm minus Fr. So alright, we have an equation now that summation of F of h, the net force along the horizontal direction, would be equal to Fm minus Fr, where Fm is the force that is causing the motion and Fr is the force acting in the direction against the motion due to friction. Now as long as this term becomes 0, the body will be in motion. Once the force causing the body to move fades out and becomes equal to the force against the motion due to the friction, then the summation of Fh will become 0, and in the end the body will be at rest. So with that, we have come to the conclusion of this first lecture on the basics of mechanics. I hope the video was useful. I will see you guys again in the next lecture. Bye bye.